Welcome to our presentation on the file system interface. In this session, we will explore the various aspects of file systems, their properties, and how they function within an operating system. A file system is a method of storing and organizing data on a storage device. It controls how data is stored and retrieved, ensuring that data is not just a large, undifferentiated body of information. Files are stored on a storage disk and remain even after a user logs off. They have names and access permissions, allowing controlled sharing. Files can be organized in complex structures to reflect their relationships. File attributes are crucial in an operating system. They include the name, identifier, location, type, size, protection, and time, date, security information, all of which help manage and secure files. The operating system differentiates various types of files, such as character special files, ordinary files, directory files, and special files, each serving different purposes and functionalities. File access methods determine how files are accessed and read into memory. Operating systems generally support single or multiple access methods, including sequential, direct random, and index sequential access. Sequential access reads records in a predefined sequence, processing information one by one. This method is commonly used by compilers to access files. Random access, also known as direct random access, allows records to be accessed directly by their address, enabling quick reading and writing. Access methods include sequential access, which involves reading and writing in sequence, and direct access, which uses fixed-length logical records for more flexible data handling. File operations include creating, writing, reading, seeking within, and deleting files. These operations are essential for managing files within a directory structure. A directory structure is a collection of nodes containing information about all files. Both the directory structure and the files reside on the disk, organizing data efficiently. File system organization involves partitioning disks and directories to manage files effectively. This structure helps in organizing and accessing data across different storage devices. Operations on directories include searching for, creating, deleting, listing, and renaming files. These actions help manage and organize files within the directory. Directory organization aims for efficiency and user convenience. It allows for quick file location, supports naming conventions, and enables logical grouping of files by properties. A single-level directory is used by all users, which can lead to naming and grouping problems due to the lack of hierarchical structure. A two-level directory provides a separate directory for each user, allowing the same file name for different users and efficient searching, though it lacks grouping capabilities. Tree-structured directories offer efficient searching and grouping capabilities. They support both absolute and relative path names, making file management more flexible. Tree-structured directories allow creating and deleting files and subdirectories within the current directory. This structure supports efficient file organization and management. Mounting is the process by which the OS makes files and directories available for users. A file system must be mounted before access, and it is mounted at a specific mount point. File sharing allows multiple users to access the same file, which is essential in multi-user systems. It can be done through protection schemes and across networks using methods like Network File System, NFS. In a multi-user system, user IDs identify users, allowing permissions and protections to be per user. Group IDs allow users to be in groups, permitting group access rights. This means that both the owner of a file or directory and the group associated with it can have specific permissions. File owners or creators should have control over what can be done with their files and by whom. This includes various types of access such as reading, writing, executing, appending, deleting, and listing files. Access lists and groups define the mode of access, such as read, write, and execute. On UNIX, Linux systems, there are three classes of users: owner, group, and public. For example, you can set specific permissions for a game file using the command chmod 761 game. Windows 7 provides a detailed access control list management system. This allows you to specify permissions for different users and groups, ensuring that only authorized users can access or modify files. Here is a sample UNIX directory listing, showing various files and directories along with their permissions, owner, group, size, and modification date. This helps in understanding who has access to what within the system.